Okay, guys. All right. A very good morning and a very warm welcome to the webinar on TensorFlow, Deep Learning with TensorFlow. So as you know, this is like a part two. Okay, this is a part two. We had the part one like a few weeks back, as a matter of fact, in September, where we discussed a little bit about deep learning, but we did not venture too deep into the coding. Okay, we kind of took like a basic code in Python, but we definitely did not venture very deep here. Okay, let me first share my screen and then we'll start talking. So as many of you might know, my name is Amritash and I'm practically a deep learning researcher and practitioner. And I have been working into the field of deep learning for over 5 years now. I've worked it in professional capacity. Even while I was doing my master's, we were using TensorFlow and Keras to build neural networks for academic assignments as well. Okay, so it has been quite some time that I have used TensorFlow as well as PyTorch. Okay, now for people who might have attended from the last session might remember this, that deep learning particularly is kind of like a machine learning technique itself. It's just a little specialized, okay, in what it does. Now, the overall discussion goes around deep learning, and I will just give a review here first, and then we'll move on and we'll have a discussion. But okay, I think. So Sonali, the recording is ongoing, but I hope you understand this is like a more of a webinar. It's not really a class, okay? So yes, recording will be provided, but try not to source this material as your learning material, okay? All right. Because here we are mostly here to give you an introduction. This will not be something way too serious, and we will be looking into basically giving you a fair bit idea that how things work. But please do not misunderstand with a class, okay, or like a full-on lecture. Okay. Yeah, Chivi, you did miss it quite a lot because we did talk about neural networks and how they work over there. So I cannot review that, unfortunately. It will take too much time. So unfortunately, that I cannot review. Okay, if you already know, great. Then no worries. Then perfectly all right. Then we can directly focus on TensorFlow. Okay. Now, the idea with deep learning or artificial neural network, right? The overall idea that we are dealing is artificial neural network. Hey guys, you can see my screen, right?
Yes, sir.
So as we like to call them, artificial neural network, AN, or in short, we call them ANN. And once you have more than like more than one hidden layer, we usually refer them as deep learning. Okay, deep learning. Now the issue with deep learning is there are quite a lot of things. Okay. And as you will go in depths of deep learning, you will realize it is not that straightforward either. Okay, there are quite a lot of things happening in deep learning that we need to do as a matter of fact. Now, yes, one could write the code from scratch in Python, C, or whichever language you prefer. So guys, when you're not talking to me, please mute yourself. Okay, by default, mute yourself. I will prefer if you have any questions, first write down in the chat. I will read it out. I have the chat open here. So please, I will prefer that you write it on the chat itself. Okay. Okay, all right. Now the issue is if you were to start writing everything from scratch, you could do it, but it would take too much time. Okay, in very simple terms, I'm going to explain. It's just going to take too much time. It's going to be too much of a hassle. And bringing the idea from research or experimentations all the way to production is no joke. It will take time. And unless you're not unless you don't have some kind of a platform or some kind of a framework, it's gonna be incredibly hard for you guys or anyone, it's just not you, anyone, to write the whole code and deploy or work with a machine learning or a deep learning module. Okay, and if you are trying to do a custom design, have fun, no doubt. I'm not gonna deny that, but it's gonna be really hard, guys. Okay, let me be very clear about this. It's gonna be really hard for you guys to write everything on your own. And this is where This is where we require some kind of a framework. Okay. So, okay, first let me ask you, in terms of software, what is a framework? Anyone? What is a framework? You can write down the answers in the chat itself. Have you heard about like .NET framework? .NET. And not always, but set of libraries, yeah, or set of libraries and protocols that are set over there to guide you, or like you can think about Django. So I know like a lot of people, whenever we say framework, they think backend only, but I understand backend is a very regularly used word, but it could be just set of libraries and protocols written, and you could design anything, not just backend. You could design anything from that. Okay, you can design the whole system using that, and that's what .NET truly is, if you really ask me, because I have done like .NET certification long back, like when I was in college. Okay, but we did see that this is like mostly a set of protocols, libraries, and predefined functions, which just makes our work easier. And we just need to extend that. In all honesty, if what we are really doing is we are taking those functions and we are extending those functions to write our own functionality. That's what truly a framework is. And something similar is required. No, I clearly said .NET. So you guys can stick with .NET for this example. When we say .NET is not just meant for backend. I know you can design backends from them, but a whole system framework can be designed based on using on backend. A lot of large application logic can be written, which might not have a singular backend as a matter. So even it deals with your databases, it deals with your front ends, it deals with your desktop application. So .NET, like a proper framework, has a much bigger utility. All right. Similarly, in Python, you could have Django. Django is particularly very well known. My first, I think, framework while working with Python was Django itself for backend development. But Django is very much into this backend development domain. You cannot design the whole software based on Django. You can mostly design something like a web application utilizing that. But the same idea exists over there. Designing the complete backend, how to deal with, how to interface with databases, how to interface with file system, user authentication, how to deal with networks, packets, protocols, right? How to design a proper middleware. If you had to design everything from scratch, it will take too much time. So what we use is Django or some kind of a framework like Flask is also there, right? And again, with different languages, like for PHP, we have Laravel and we have Ruby on Rails, right? And then we have Node.js, React.js. There are so many frameworks that are available. React is all the more on the front side, but there is some server-side rendering over there. But Node.js, I think, is a much better example. No, Mohammed, that's the example. I'm not saying you will have to learn .NET today. Okay, that's not what we are saying. We are using it as an example to give you an idea what is a framework in terms of a software. Okay, similarly, what I'm trying to say is to run deep neural networks, you will require a lot of mathematical packages. Okay, you will require different kind of libraries around GPU acceleration. One particularly is called CUDA. Okay, CUDA is provided by NVIDIA. So if you have NVIDIA cards, so NVIDIA have these CUDA cores. Okay, so you will need to install CUDA toolkit and CUDNN. That's the deep neural network library and written in C++. And these libraries, again, you will need to know how to interface with them, right? And again, this can become extremely hectic for us, okay, to manage all of this. And then also think about testing, production, again, monitoring, re-verification, maybe retraining, redeployment, continuous CI/CD. We have to think about so many things, right? Again, we want to think about the model being utilized on a server side, maybe utilized within a mobile app or within a front end. Okay, so maybe it is running on a browser. So uh, there are a lot of things that has to be interoperable here, which again, designing everything on our own. will require too much of detailed knowledge and a level of engineering skills that most of the engineers don't possess on their own. Most of them don't have. Even I will agree, I don't have all the skills to do everything from scratch. Okay, maybe I can write a small deep neural network code from scratch if required, but I cannot start deploying that model everywhere and make it work everywhere. It will be really hard for me to do. But this is where framework comes, and this is what TensorFlow truly is. Okay, so this is the whole idea that why do we use frameworks? And TensorFlow by Google, it was released in November 2015 commercially. Okay, and this has become the right machine learning or deep learning framework. Okay, and you could utilize it for development of almost any kind of neural network. Okay, any kind. So TensorFlow is again like a framework, as I said, it's like a set of libraries. And again, multiple things can be done. You could prepare data, you could build ML models or deep learning models. You could deploy these models, and then you also can implement via ML ops. ML ops is a fancy way of saying machine learning ops or operations, or basically it's very similar to like DevOps. Okay. So it is like you are putting these machine learning models into production system. Okay. So all of that can be done, and a lot of examples you can see on internet, like this is a post detection example, which you're seeing on their website. A lot of these examples, which are seriously deep learning based, can be utilized in order to develop our solutions and utilize it within various devices. And plus we can find a lot of pre-trained models here. Okay, so many times it's not possible for an average user to redesign or write everything on their own. So that might not happen on their own. So what you inherently do is you take a pre-trained model, let's say provided by Google, Facebook, Microsoft. Either you use it directly for your use case or you retrain it, which will require less computational effort. Okay, that will require less amount of computational effort as a matter. Okay. So this is something that's amazing, and we can like think about it, and we could definitely look into that, why using framework would be incredibly helpful, and how we can actually write a small neural network using these frameworks. So these two sessions, today and tomorrow, are going to be dedicated using TensorFlow and Keras, and we will try to design small neural networks. Okay, good. Hey, Julia, I'm not going to talk about AWS because this is not the class for that. Okay, so there would be another sessions around those things, but this is not the class to talk about AWS. Actually, I will say, when you say freshers, like we will have to understand, like, do you mean college freshers, or you are just simply just switching your fields and you are thinking you are a fresher in data science? So if you're a college fresher, I will say get some software learning or software development experience as well, if possible. Some backend development, app development, or proper software development that we do. If you have that experience, that will actually make it far easier to work in data science or deep learning field, because again, these are also development fields, and unless you do not know how to utilize them completely, it would be really hard, right? Okay. So, Mohammed, I will say you should take some programming classes first. Statistics is good enough, but unless you do not have proper software development background, means I'm not saying proper means 10 years or 5 years, no, just that you could develop something. Okay, that much you need to have. If you have software development, yes, then Ayush, I think it will be a perfect way to switch into deep learning or data science, especially in a development role. Then it is going to be easier for you. No, Chidvi, it is like very ad hoc. I very rarely get times for these things. So whenever I get time, I allow this. But I am not like very regularly into webinars. Okay, all right. So Chidvi and Mohammed, I think for this you will have to talk to Learnbay. I cannot miss. See, there are a lot of modules, and even I do not know all the modules. I will say, why don't you guys go ahead and at least look into some kind of an advanced AI/ML for tech professionals, or you guys could also look into some kind of a data engineering, or you can look into full stack. I will say, okay, if you guys want to look into how to develop software properly, I think full stack course is something that you guys should be looking at. If you do not want to directly jump into deep learning and machine learning, I think full stack software development program is something that you guys should definitely go through. So full stack is something that I could recommend wholeheartedly to all of you. Okay, anyone who is willing to just start from scratch. And you could apply for counseling here. So if you are not sure, Learnbay will provide you excellent counseling. So just click on this button, fill out a small form, and Learnbay will reach out to you. And you guys can get the counseling that you need, and they can guide you far better in the software development domain than me. And if you feel that with AI and ML, then definitely we can talk about it right now. Okay, TensorFlow Lite is a version of TensorFlow which has been introduced to develop against, or sorry, for mobile apps. Okay, mobile apps cannot take a very large model, so we actually have to come up with a smaller model and a smaller framework to make them run or make them work with. All right, so TensorFlow Lite is just a version which you can utilize to deploy within the mobile apps. Okay, I'm back now. So next question. Does TensorFlow use convolutional neural networks? See, TensorFlow is the framework from which you can build a convolutional neural network. Okay, it does not use this convolutional neural network. From using TensorFlow and Keras, we can build a convolutional neural network. All right. Any other question by anyone? How can we combine blockchain technology and AI? So, I think that's a very like wide question, and there are like so many answers. I cannot even like go in depth about that right now. So maybe we can tackle this in some other webinar, but this is not a discussion for today. Okay, this is a very wide discussion. Okay. So guys, actually, I want to start with the TensorFlow introduction, and you can see I have written TensorFlow 2 actually. So there have been significant changes from the time TensorFlow was released from November 2015 all the way till October of 2022. So you can understand we are almost going to be touching 7 years. So there has been a lot of development in TensorFlow. Okay. And very soon TensorFlow 3 will come. So maybe I will update it to TensorFlow 3 by that time. But TensorFlow 2 is something that we mostly are utilizing. Most of us are mostly utilizing some variant of TensorFlow 2 itself, like 2.8, 2.9, something like that we are kind of going through right now. Now, this notebook that I have just opened is called Google Collab. Okay. Now, this is openly available freely to everyone, whoever is having a Gmail ID. So you can just search for collab.research.google.com and it will open up a notebook for you. It's just like a Jupyter notebook. Okay. So if anyone has worked on Jupyter notebook, you will understand it's very similar to what we are doing over there. So it's fundamentally just like a Jupyter notebook that we are inherently utilizing. Ajit, don't annotate, okay? Okay. So let me do one thing. Actually, why don't I share this link first and then we will continue and we'll discuss point by point. Okay. So one moment. So I have pasted the link. Can you guys see the link in the chat right now? Yes, very good. So you guys could use this. Now you cannot make any changes to my file. Okay. You can just run it locally, but you cannot make any changes to my file online at least. Okay. You can download it and then make changes. So guys, TensorFlow 2 is like extensive redesign, and this is why it is significant, okay, because there has been extensive redesign over the years, and in 2019, TensorFlow 2 came out, okay, so like almost after 4 years when originally it was launched. And it has embraced different kind of paradigms. Initially, like there was no eager execution, but now we are dealing with eager execution. And this runtime and the way it was executing the code also has been changed a lot, as a matter of fact, as we have progressed here. Okay. Okay. Now, there are advantages and disadvantages. Yeah, if there are advantages or disadvantages that we could talk about, but I think first, a small intro is required. Okay. Why we even require TensorFlow? Now, as I told you, TensorFlow is this framework for building machine learning and specifically deep learning tools. And the simple reason is why people use TensorFlow is it simplifies your model building task. It simplifies your model building task. And TensorFlow basically offers you multiple levels of abstraction, okay, so that you can choose the right one for your needs. Okay. Abstraction, when I say, I simply mean to say, if you had to write a function, or if you had to define, let's say, some kind of a sigmoid function, you don't have to write the function on your own. These kind of functions are already available within the TensorFlow library. Okay. So it makes our life very easy that so many of the processes that we are worried or trying to work about are already kind of implemented, and it just makes our task so very easy. Okay. Now, if you want flexibility, you could go ahead and start dealing with compiled graphs, or you could start dealing with how to change and even tinker with the hardware configuration if you require. Okay, so all of that is totally viable, and we can definitely do this. Then we also have something like robust production anywhere, like or everywhere, like I should say now, because TensorFlow has grown leaps and bounds over the years. And what we have just found is that just deploying on one machine is not good enough. You have to understand this. We always will have varied use cases. Sometimes it has to be deployed on a server, sometime on a standalone on-prem device, or maybe it has to be put on some kind of a internal cloud. A lot of companies will have on-prem cloud. Okay, some people might just want to deploy it separately on each mobile app, or you want to deploy it on a website browser. So browser is mostly your client side. Okay. So for all these different requirements, we cannot be having different kind of platforms. So rather than TensorFlow provides different variations where you could utilize and you could deploy these models in different use cases, and you don't have to rewrite most of the code. And that helps us in deployment and expanding our work into different applications and different use cases. Now, of course, not just the production part, even research and experimentation becomes really easy. And you could build and train a state-of-the-art model. So just retrain or reutilize some state-of-the-art model that's provided by TensorFlow that is already very optimized, if I have to say it. And that would work perfectly fine. And with minimal amount of coding, you will be able to utilize TensorFlow on your machine, as well as you will be able to get the results that you are looking for. Now, when I say with minimal amount of coding, you will get results, there's a small caveat here. Okay. Now, for acceleration, TensorFlow or almost all kind of deep learning utilizes some kind of a CUDA core. Okay. So NVIDIA has a patent here. Okay. So let's say we will have to talk about some kind of a graphics card. So let's say NVIDIA 3080X or RTX, I should write actually. Okay. So you will need to have some kind of graphics card in either your system, like it could be a desktop, it could be your laptop, it could be a server as well. It could be a server as well. And in the specs, particularly, you have to go into specs, and what you have to read about is this part. How many CUDA cores it has. More the amount of CUDA cores it has. And of course, being faster and having more memory will definitely help us, no doubt about it. But having more number of CUDA cores means more parallelization. And most of the, I think, most of the work that we do in machine learning and even in deep learning particularly is fundamentally kind of expanding on the, or like kind of parallelizing the matrix multiplication and matrix operations. Okay. And these things are NVIDIA CUDA cores is something like these are like very specialized cores, which are only good for mathematical processing, and most of the AI is fundamentally mathematical. So we don't have to worry about it. Okay. And you can see that 10,240 cores are available on a single graphics card these days. So this makes our life a little easier while training the model. And this is something that I will recommend to everyone, that if you are looking into it, you will require some kind of a CUDA core or some kind of a graphics card with CUDA cores, and NVIDIA will sell these things. Okay. Although why I go ahead and deal with Google Collab is because in the runtime, we could go ahead and select the hardware accelerator, and Google Colab does provide you free GPU. Although there are some kind of intrinsic restriction they put, okay, which they will not tell you upfront many times. So they can also ban you if you are using it for too long or something like that. But if you just use it for short bursts, it should be completely okay. If you are looking to become a data scientist who is gonna be actually deploying and working with different requirements and might have to worry about deployment, development and deployment, yes. Like having a good knowledge about deep learning, machine learning would definitely help you out. Okay. Now, guys, the thing is, okay, fine. Let's say if you say, okay, but I don't have an NVIDIA card, what should I do? So again, two answers. Either go to Google Collab, they will provide you the free graphics card, even restricted, I understand, or you could install the normal version, which is CPU only. So guys, if anyone wants to install it right now in their local systems, so if you don't have an NVIDIA card, you will run this command in your, let's say, Anaconda prompt or wherever your Python installation is pointed at. So you will have to do this pip install upgrade TensorFlow. Now this will only install this is only gonna install the CPU version. Okay, please remove the comments of this. So this is gonna only put the CPU version. So the acceleration that you will get will not be that amazing or something. Okay, but for people who have NVIDIA, they should use upgrade TensorFlow -GPU. Okay, where it will work on GPU and CPU both. Best idea would be for now, while you're learning, just stick to Google Colab, change the runtime to GPU, and by default, TensorFlow GPU is installed on Google Colab. So you don't have to really worry and you don't have to install or reinstall anything. All of this is already pre-installed. So I personally feel that this should work out perfectly fine for us while you guys are in learning mode. Okay. And because I will tell you it is already pre-installed, what we can do is once it is pre-installed or it is installed, you can import TensorFlow as TF. TensorFlow is the package, TF is the alias for that package. And then we can actually go ahead and check the version. So how do you check? You write TF double underscore version double underscore. Actually, this is true for any Python libraries, just not TensorFlow. For any Python library, if you want to check the version, just do name that library dot double underscore version double underscore, and then it will give you the version. So let's see what is the current version it is running right now. And you can see 2.8.2 is running on Google Colab. And I'm fairly sure that even if you were to run this one on your instance or your connected instance of Google Colab, you should get the similar version because Google maintains these things and Google can ensure that which version is there. Okay. Okay. Now, eager execution is something that you guys don't have to worry anymore. Earlier, this was a problem because the code will not run automatically on its own unless you do not define the whole graph and you were to give a session and you were to run the session. But if you just want to check, there is a simple flag tf.executing eagerly, and it will return you true that yes, it is running, it is enabled. Okay, so it will run operations immediately. So eager execution is like this. Okay, if you just want to do 2 plus 2, you don't have to wait for the result here. And in Python, in most of the languages, this is totally supported. You don't have to do anything else. You don't have to initialize anything. You can just simply write 2 plus 2 and it should give you the results. But in the prior versions, especially when TensorFlow started, okay, this was not possible. We could not just do 2 plus 2 in TensorFlow. And I could show you that example later. But you could not just simply walk in and say, oh, I will just read 2 plus 2 and our result should be 4. No, it will not do that actually. And we are going to show you that nowadays it is totally possible. Right now, this one that I have used, 2 plus 2, is Python one, but I will show you similar example using TensorFlow. Now, okay, guys. Now TensorFlow that we have downloaded is a Python one. Okay, it basically is a Python library for us, or Python framework, if you have to say it. Okay. Now, another thing that you ideally want to check again for acceleration to run our deep learning models or train our deep learning models a little faster is GPU itself. Okay. So basically you should check is GPU available for use. And again, here a simple test should get you done, or you can get this tf.test is GPU available. And if it is true, then it will say yes, your GPU is available. Otherwise, it will say GPU is not available. And it will also mention what is the contact ID or something. Okay. So here you can clearly see that is your GPU available for use? Yes, it says yes, it is there. And it does tell your devices that are available is physical device GPU 0. So when we say 0, it does not mean there is no GPU. It simply means it is a 0th index. It is just simply referring as 0th index, or in computer science, like our counting starts from 0. Okay. Okay. The counting starts from 0. And you can see we have one GPU available to us, and we can actually list this physical device properly if we wanted to. And you can also list the CPU device. What's happening? Okay, you could also list physical devices like CPU, and you can also see we do also have a CPU device available here. Now, if you want to learn which kind of GPU or what you are learning, there is a command. Now, this will be run from command line. Okay, you cannot run it within Python. Okay, so to run that, we will just use back this exclamation mark, and exclamation mark after that we'll write NVIDIA-SMI -L. And if I do this, okay, it will tell you which card you have. So this is called Tesla T4, and you can search about on Google about this. What is the Tesla T4? And these are meant for data centers. Okay, these cards are meant for your data centers. Okay. Okay, now Tesla T4 is not really a new card anymore. It is a little old if you ask me, but this is why these things are freely available for us. Okay, so Tesla T4 is again like available on Google Cloud and Azure as well as on AWS, and it will show you that at the time when it came out, Tesla was again like a state-of-art performance that it was providing, and you could see they have tried to give you the inference speed, and they have tried to tell you how fast it is. So guys, what you will see on these are different neural networks. So Resonant 50, Deep Speech, GNMT, okay. They have just tried to give you a scenario there, how fast these things can go. So can you see what is the acceleration level compared to a normal CPU? CPU is your, say, a central processing unit, let's say, as an Intel. Okay. Although they have compared here, okay. So just to be clear, they have compared Tesla T4 versus Xeon Gold 6140 CPU, which is again a server grade CPU, and you can see the performance that we are getting. It's fast, right? It's really fast. And for a lot of our use cases, this is something what we are looking for. So checking for the NVIDIA or checking for the card will definitely help you out. Okay. And again, one could do NVIDIA SMI, run this command simply, and you can get a complete detail that, okay, the card is running and how much it is consuming. And you can see right now I'm not running any process. So it is kind of on the standby mode. So it is still consuming 27 watts. At maximum, it will consume 70 watts. When it is running, at maximum, it is going to consume 70 watts. And we have something like 15.1 GB of video RAM. Okay, so these details can be seen by a simple command like NVIDIA SMI. Now, let me show you a runtime comparison first. Why do we even care about all this? Okay. One moment. Okay. Hubert, are you saying something? Hey guys, if you have any doubts or any questions, please keep writing it in the chat itself. I'm reading the chat. So if you have any questions, I will definitely respond to you. Okay. Okay. So guys, the plan here is very simple. We want to do a speed test. Okay, a small speed test, and basically want to see how fast a Tesla T4 could be for simple mathematical operations compared to the CPU that we have here. All right. So we want to do this simple testing. You can ignore the Google Drive thing right now. Okay, I have not covered that. There is a different way of doing things. So you can ignore the Google Drive part. Okay. Okay. Now, guys, one thing that I want to understand is we want to do a comparison between the CPU and the GPU. Okay. So we can choose when we are running some operations, we can literally choose things as we want. And we could work here and we could say that, okay, when we choose such scenarios, so we can choose, let's say first, in the first one scenario, we'll choose CPU as our device of execution, okay? So we will start our timer here, and then we will try to compare or calculate all the, basically we'll try to do a simple computation, okay? We'll initialize a massive matrix of 100 cross 100 cross 100 into 3. So this is like a large number that we are getting. Now, what we are going to do is we are going to sum all the numbers. Okay, we are going to take this large number array and we are just going to sum all of these numbers. Okay, so this is like a simple process that we have to do. And then once the summation is done, we will end the CPU or we will stop the CPU. And we will basically stop the timing here. And then we'll basically get the end CPU, which will be how many times or how much seconds or milliseconds or microseconds it actually took to run the whole thing. Now we'll do the exact same thing for GPU as well. We will do the exact same thing for GPU, and fundamentally we will compare how much speed up we are getting. So guys, do you want to bet like how much, or do you want to like at least predict how fast it is going to be? Okay, let me show you. And many times the fetch initially, right now you will see the fetch initially is hardly anything. You will like, okay, what's the big deal here? Right. But once I read on it, and you will see that because first time it has to load in the memory, and that can be a small bottleneck. If I were to just run it or rerun it again and again, you will consistently see it is 20, 29 times or 30 times faster than the CPU I have. And again, T4 is not a by any measure a new card. Okay, understand. T4 I think was released somewhere around 2017, 18. So it's not really a new card that we are using. There are much, much faster cards. It's just that those faster cards are not going to be freely available. But guys, 29x, even on simple summation, we are getting. And again, it will vary, but around 20, 30x, we get the acceleration. So this is something that we are looking. Okay, so understand that summation took like 0.05 seconds, 0.05, okay, 1/20th of second on the CPU, but it takes like 0.001638 seconds only on the GPU. So I hope you can see the acceleration, how fast it can go, even on a freely available card through Google Collab. Now, if we have to deal with TensorFlow, we will have to deal with its data types and how it executes. Okay, so we'll have to see all of that. But before that, if I even had to go there, let me ask you a simple question. Guys, do you understand what is a constant and what is a variable? Okay, so which does not change through our code is constant, right? Yes, yes. Some value which does not changes is something throughout the code execution is called a constant. Okay. Okay. Right. And then what is the variable? Okay. Chidvi, what is the error that you're getting? It says invalid syntax at the eager execution part. So, Chidvi, may I ask you, where are you running this code on Google Collab itself? Let me see. Maybe things might have changed. Okay, let me see. See, I ran that code, right? This one is running for me. No, actually, you are running on Google Collab, right? Just to confirm this. Okay, so you should not be getting this issue because you can clearly see I've run this code. See, TF executing eagerly, and the whole code has executed. Okay, yeah, just be careful. Do not type anything. Okay, just be careful over there. Okay. So guys, absolutely right. Variable is something that varies over the time of the execution of the code. And constant is something like 5. Okay, if I were to write 5 or like pi value. Okay, pi is what? Okay, so like within math module, you can have math.pi. Okay, or math.e. What is e? Anyone knows this value? It is referred as Euler's constant. It is 2.718. Yeah, the thing is these are constant. These values do not change. Okay, pi value cannot change to anything else. It will stay 22/7 or whatever the approximation they have utilized within Python. Similarly, the approximation of e that has been utilized within Python is let's say 2.718. That is not going to change. This is going to be called constant. So similarly, TF also has these two types, constants and variables. Okay, constants and variables. Now, before that, before I go into all that, I need to define a word here. So actually TensorFlow, as you might understand, is defined using two words, tensor and flow. It's inherently utilizing two words, tensor and flow. Okay, now what is tensor and what is a flow? Okay, so let me explain both parts easily to you. Tensor is just a very fancy way of saying matrix. Okay, it's a very fancy way of saying high-dimensional data in a fixed or a record. Yeah, let's say fixed schema that we are using. Okay, so in TensorFlow, okay, or tensor is kind of a matrix or is utilized to represent high-dimensional data. So a tensor of rank 0 is nothing but a scalar. Okay, it's just a scalar like 26. Okay, that is a scalar. Okay, just the value of 26. Rank 1 is inherently vector. And let's say if I had to write it like this, 26, 27, 30. Sorry, comma, and then 30. Then I'm dealing with a vector. This is rank 1. And similarly, you could keep introducing, and then how the rank 2 will look like to us. Tensor of rank 2 will look like a 2D matrix, right? Or a 2D array, as you like to call it. So it should look something like this, right? This is like your 2D array. Or if I have to represent them programmatically, it should look something like this. So the first one is 26, 27, and 30. And the next one is, let's say, next one is 51, 52, and 48. And this is the 2D matrix or a 2D array. And this is of rank 2, or you can also call it a rank 2 tensor. So tensor is just a very fancy way of saying matrix of any dimension that we are dealing. It's very similar to ND array in NumPy. Okay, ND array used to stand for n-dimensional array, right? ND array stands for n-dimensional arrays. Similarly, you can just understand with whatever rank you want to work on, you could just work the similar idea with tensor. So anything that becomes a TensorFlow object is a tensor inherently. Okay, any data that we store is inherently a tensor. Similarly, any data that we store in NumPy is inherently stored in an array. Yeah. No, so but the NumPy does not has all the support for deep learning and all the advanced libraries that are required for it. Yeah, I would love that if it would all happen in NumPy itself, but unfortunately, it's not, right? NumPy is mostly for numerical computation, but it does not really specialize with deep learning and the solution that we're looking to. Shruti, I just told you tensor is just literally like a NumPy array or like an array itself. Like you can just imagine it like an n-dimensional array to store the data. And guys, it's okay because I think I told you at the start, like again, in a webinar sense, we cannot teach you everything. It's very hard actually, because there's a lot of background that's required. If someone does not know NumPy and Python properly, I understand the confusion that you will not be able to understand. So don't worry about it. This is like we are just trying to provide you knowledge. But again, as I've told you, webinar is no substitute for a full-fledged class. Okay, it's not a substitute. At some point, you will have to do it thoroughly and properly step by step. Yeah, Harsha, for acceleration purposes, it is required that we convert everything to matrix or a tensor, and otherwise we will not be able to accelerate the processes. Good. So what you could do is you could define tf.constant type, okay, and you could provide the value. If you want, you can define the d type. D type is data type. Now, as you might know, some who have done programming at least might know that within TensorFlow or any programming language, we do have different data types. So we have the floating data points, okay, and then we also have integer data types, Boolean. We have complex supported in Python. We could have a string, right, a string or character, okay, and even bitwise of like basically binary data types are of course supported. But here we are less interested in float 64. So 64 bits information about this float, it's basically going to be called a double. And let's say I want to store a 4.0 here. So C will store this constant and the 4.0 is now going to be treated as a constant. Okay, because C inherently has become a constant. And if I were to print C, what do you see here? Right. What you see is there is no shape given. So if the shape is not given, you would immediately deal or understand it is a scalar value. It is like you have the magnitude, but there is no direction. Okay. And you can see 4.0 is the value and the d type is float 64. So you get this information. But the most important information that I think you should be looking at is tf.tensor. The data type or the type has become tf tensor. It's no more a Python integer or a floating point. Okay. It has become a tf.tensor. So anything that I try to store or work with in TensorFlow will become a tensor. Is that okay? Good. Similarly, we can store high dimensional data. Okay, so the one good simple thing you could do is you could take a NumPy array and you could try to transfer that to a TensorFlow or tf.tensor, and that is extremely easily done. You guys could clearly see what I've just done here. I have taken a 2D array, 1, 2, 3, and then 4, 5, 6. And right now you can see the d type is integer 64. So if something right d type as integer 64, it inherently means this is a Python data type. Okay. Okay. But once I pass this d, which is an array, to tf.constant, now you will see there is a change here. Now you will see the d, it has become a tf.tensor first. You guys can clearly see now it has become a tf.tensor. The array is stored and you can even see the shape here, 2, 3. And the d type looks int64. But actually that's not the truth, because if I were to print the d type separately, it will actually tell you it is tf int64. Again, guys, they are same things, but tf is maintaining, because I told you that's framework, it maintains everything from the base. Okay, so it is maintaining or recording or having all these informations, everything from base, and ensuring that all of the data types and all the tensors are controlled by it, because it needs to provide you with the acceleration to run the deep learning modules. And if we were not to control this from ground up, this will break or this might not give the results that we are looking for. Okay. Sorry, where is the ID you are seeing? Like, I do not see something like ID or something. Did you meant to see integer? I cannot see what is ID here, but if you were asking something about integer is a data type, which is used to store these discrete integer values that we have in our number systems. Okay. Let's say you have a 1D array, okay? You start with a vector, let's say 1, 0. But let's say I want to convert it to a 2D array, something like this, where each element is a part of its unique array. Then what should I do? Now, in NumPy, we do have something called expand dimensions. And guys, a lot of functions are actually very similarly named here as well, just for ease of working here. So you can see I am taking b, which is tf.constant, and we have 1, 0, 1. Okay. And print b. So we will show you that tensor first. And then we will do expand dimension b, 1. So the overall dimensions are to be expanded by 1. And let's observe what happens after. The tensor is 1,101 and shape is 3, nothing. Okay, so it's like a vector. Okay, and the d type is by default 832. So if you do not define it, will automatically try to know or guess, not guess, like it will typecast it to the most favorably used data type. But once I convert it, you will see the shape has changed to 3, 1. Integer 32 is the type. But guys, what is the major difference between the previous one and this one now? Yeah, sure, you can. And we do this all the time in operations. And whenever we try to work on this one, yeah, we do change the dimensionality to suit our representations or the way matrix multiplication works. We do that actually all the time. Chidri, yes, of course you can do that. For the picture dimension, you could increase, but you have to be careful what you are increasing into. Otherwise, it would be a black spot or a black area or something that you might have created, unless you specify some colors for that area. But yes, we can do that. Yeah, yes, you can use JSON files as well as CSV files using TensorFlow. Yeah, guys. So I also asked you a question. So what really changed here? Can you tell me what really changed here? Yeah, one-dimensional or one-dimensional array has changed to a two-dimensional scenario. Yes, absolutely correct. Okay. Similarly, it does has a random module as well. Now, I'm not sure how many of you know about random module in Python or NumPy itself, but guys, at many times within machine learning and deep learning, we do require some kind of randomization of data or some kind of initialization of weights or parameters, as we like to call them. And for that purposes, many times some kind of a random number generator is required. So what I'm trying to do here is, I am trying to take a normal distribution, as you might know as a Gaussian distribution or like a bell curve, right? So where most of the data is centered around the mean. Okay. So what we are trying to do here is we are gonna take a shape of 10, 10. We will take mean as 0 and standard deviation as 1. Okay. So most of the data that we will be end up generating randomly will be from -3 to +3. Okay, Gaussian distribution, of course, will go from -infinity till +infinity. But in probability scenario, I would like to say like it would look like 98.73% data ideally should be coming from this -3 to +3 range. Okay. So if someone knows Gaussian distribution and its value, you will understand why it is happening. But if you don't understand it, please don't sweat about it. Okay, don't worry about it. If you do not know about this Gaussian, no need to worry. So if I wanted to initialize a 10 by 10 array with all the random numbers from it drawn from a normal distribution, and this is how, let's say, it is gonna look like. You can see this is a 10 by 10 array. It has float 32. And this is the array that we are internally having. And you guys can see it just has random values, and most of the values, I am guaranteeing, would be between -3 to +3. If you do not know this, don't worry. Okay, I clearly saw, but we cannot go back to a distribution. That's a statistics issue. And if you do not know it, don't worry about that part. Okay, all right. And similarly, if someone wants a uniform distribution, you can also generate a uniform distribution. That's equally simple, right? Uniform distribution from the starting to that endpoint. So from min value to maximum value, you would have like a uniform distribution. I know I have started it from 0. Okay, but here I'm trying to show, okay, or one can show it from 0 to 10. That's also okay. All right. So basically you have uniform probabilities occurring, and here we are kind of giving the minimum value 0, maximum value as 10, but we have defined it as int32. So now you can clearly see that I will only get integers from this range. Okay, not floating points. But if I were had to set float 32, then I should have gotten float 32. Floating point value. And you can clearly see we are getting uniformly shaped outcomes. Okay. And why it is done? Because many times initializations are required. Okay, many times initializations are required. And okay, so all of that mostly we were thinking about were constants. Now, what is the variable? Yeah, this value or the variable holds a reference which can be again reference to some other direction or some other address pointer. Okay, so these values can be updated. This is what fundamentally it means. Okay, again, a lot of times in neural networks, either to simulate some data or even just start with different kind of weights and biases, we might have to do all this. So what we do here is we take random.normal. Again, 1,5 is the shape, 0 is the mean, and 1 is the standard deviation. And then we pass all that array into inits, that is called inits variables, just to understand. And we make it a variable, and let me show you what will happen. It will give it internal name. Okay, it just does it. You can also specify names if you want to. By default, it has, if you do not provide, let's say if it's the first initialization, it will be called variable 0. Shape is 1,5. You can clearly see float 32 has been determined, and the array is already provided. So this is your randomly chosen array. Okay. Okay, and that is the information that we have already gotten. Okay. The good news is this inits variable can be updated as the code execution will go. Okay. So guys, let's do one thing. Let's take a 5-minute break, and after 5-minute breaks, we are gonna kind of resume the session and we'll discuss a little bit more about the variables. Okay. So guys, taking a 5-minute break. Okay.
Okay, sir.
Hey guys, I was on a break. I guess I did mention that. Okay, all right. So I'm back for the break. Okay, all right. All right. Actually, from yesterday night, I started sneezing, so I need to take a little breather, unfortunately. Otherwise, this break was not really necessary, but it has just happened, unfortunately. Okay, all right. Guys, first, till this point, or any, actually, you know what? Let's do one thing. Let's dedicate next 5 minutes for Q&A because I'm seeing that people are asking questions regularly. So first, let's have 5 minutes just meant for Q&A, and then again we will continue with where we left off. Okay, so any general Q&A as well, because I could not answer that. So if you have any other questions, you can ask. Otherwise, I will continue with whatever we were doing. So Harsha, today itself is we are gonna kind of working on this file itself. There is this is like a TensorFlow introduction, and tomorrow we will try to use Keras, which is a library within TensorFlow, and we will utilize Keras to build small neural networks. As you know, that this is like a second addition, or like it's the second part to deep learning with TensorFlow. But because you cannot cover deep learning with TensorFlow in one go, we had to break it down in the 2 webinars. Depends, like different institutes and different people have different kind of courses. For deep learning, I think the way one should look at is you should try to cover the basics first, deep learning basics, try to learn at least one of the frameworks, either PyTorch or TensorFlow. I'm okay with either of those. Okay. But whatever you learn, try to go a little deeper over there. So try to do projects in convolutional neural networks, autoencoders, generative adversarial networks, and even transformers. Transformers are the state of the art these days around text, particularly with language generation and text translation. Harsha, see, one could utilize it, but that's not really the best use case of a neural network. Okay, that's not really the best use case of a neural network for clustering problems. Okay, yeah, some books or some tutorials that. One moment. So one book I think I will recommend to everyone first at the very start. This is called Grokking Deep Learning, and I think this is a great book for people who are starting in this field. Okay, so this is a book by Andrew W. Trask, and he has written an amazing book. Now, this is a very intuitive kind of book. Okay, this is like a very intuitive kind of book that based on intuition you will understand, but I will not say it is very rigorously theoretical or something. There are different books for that, but this is not that. But you can find this PDF way too easily on internet. So I will really recommend all of you to kind of go through this. So then we basically again talked about like what we covered already, and we started talking why TensorFlow is required and what can we do with TensorFlow, and we were just going through TensorFlow data types. And once you want to go towards NLP as a matter of fact, so I think Christopher Manning has written an amazing book. So let me see, Christopher. No, let me see. Okay. I'm forgetting the name. There's a very good book. Yeah, Deep Learning for Natural Language Processing. This is the book I can recommend wholeheartedly to you guys. That if you guys want to look into a new book, I think this is amazing one. And I think the new edition is kind of coming out really soon. So you guys could definitely look into deep learning for natural language processing. And this could definitely help you out. And this will cover the aspects of natural language as well as with deep learning as well. Good. Okay, very good. Okay, heading back and discussing it. So because inherently we are dealing with variables now, we can update the variables. What it means is we can change their values as the code execution goes through. So let's initialize a random variable. Let's call it initial value. Okay. And okay, let's say I create an initial value variable shape 2, 2, d type is float 32. And you can see we have 4 values right here. Okay. Now I will create something called new value. Okay, new value is another similarly shaped random normal distribution. But again, of course, because random every time we will get some different values. Okay. And what we are going to do is we are going to assign the new value to A, okay, or we are going to assign this new value to A. And once this is assigned, okay, so A is, as you can see, initial values inherently. So I would want you to see, or I want you to observe this very clearly. Okay. That this is what we are going to get, and this is what we are going to get back at the end of the day. Okay, and let me run this. And what will happen is, so this loop, this assert will basically throw an error if something does not matches. If the whole thing matches as it is, there would be no error. And you can clearly see that once the assignment is done. So this is A. Okay, this is A. Or let me show you A. Okay. But once the assignment is done, you can clearly see that. And if I were to print out the new value, you will be able to see that this is the new value. So value of A has been passed to a new value, which was different. Okay, which was different earlier. And you could see that that argument with A is different altogether. So A had a different value altogether. Now, if I were to print A and if I were to print new value, you will see same values because new value has been basically pointed towards A, or A has been pointed to new value, and it is going to have the same representation. It's going to have the same values, and you can match both of them. So basically, using the assign function, I was able to assign or point A towards the new value. All right. Similarly, there are functions we can do assign add. This will do addition. Okay. So I could take new values and I can add them to the existing values. So I will run this, and again, I will check for element to element. And if this logic does not satisfy, so new value plus added value, if it does not comes equal to aij for that index value exactly, it is going to throw an error. But if it does not throw an error, it means it matches successful and everything is as we planned or as we wrote down. Okay. So you can see that again, we have gotten the added values and no error has been thrown. It means it matches the logic. And similarly, we can do complex operations, guys. Okay, so guys, what's happening here in this code block? What's happening? The highlighted one. What you see is there are operations in sequence we are trying to do. So, okay, let's say it like this. Let me show you what we really mean to say. So we have A, which is a 2D array or like a tensor, you can say. Okay, and similarly, we have B, and we have an array. Now, first operation is the mathematical operation is addition. And the outcome is C, which is again a tensor, let's say 2D, C. And then what we do after that? Let's say power of 2. Okay, this means power of 2. Okay. So we do power of 2 and the outcome is D, which is again a 2D tensor. And similarly, we put e to the power x, or whatever the input came, we just put exponential. And again, the outcome is E, which is again a tensor. Okay, so this is like tensor. You can see like tensor is flowing, right? So, okay, tensor is the data. Okay, if I had to say it very similarly, tensor is your data representation. Okay, data. And flow is your computation. Flow is your computation. So now you understand what do we really mean by this? It is like data computation. There is a very fancy way of saying TensorFlow. Okay, so we basically are doing step-by-step operations, and I can show you that operation, how it goes through. And you can see these outcomes or these processes are running one by one. And we can get C, D, E, and all of these have been done. And we can utilize them. And again, like we can do a lot of things, guys. And again, we don't have time to go through everything, but still, I will give you a brief about these things. You can concatenate tensors. Okay, what is concatenation? So let's say you had two tensors, okay, A and B. So I could concatenate them, make a bigger tensor. Now, concatenation does not mean addition. It is just like placing them together, making them a bigger tensor. Okay. So what I'm trying to do here is, and because these are variables, we can change them. We can take these values and concatenate them. So we can take A and B, and axis 1 means column and axis 0 means rows. Okay. And we can concatenate these values, thus getting our outcome here. Okay. And you can see the outcome here. And one is across the columns or using the columns, and one is across the rows itself. Okay. And one could write simple logic as well if you want to, like A is equal to B. You could do that assignment, and you could get the outcomes over there as well. And you can see the AB concatenated and how that outcome is also coming. One could initialize all the tensors like zeros and ones, very similar to what we do in NumPy. So there are functions, okay, for zero as well. There is a function called tf.zeros. So you just need to provide a shape of the array, and all the array will be created, but it would be initialized with all zeros. Similarly, I could do the same thing for tf.1. I will give the shape, and data type is optional. You can give provide, you can choose not to provide. And it will initialize all those tensors with zeros in first scenario, and in the other scenario, it will be populated with all ones. So many times when we are doing initialization, it becomes extremely easy. Similarly, we can reshape it. Okay, so what is the reshaping? Anyone knows this? Changing dimensions of array. Okay, but there is a constraint here. Anyone knows the constraint? Not just 1D to 2D, you can actually make it much deeper if you want. You can have 1D and you can convert it to 4D as well, if you have the number of elements. But there is one rule or one constraint that one needs to remember while reshaping. Does anyone knows that? The number of elements should be same. So if your initial shape is 8 cross 1, okay, so total number of elements you have is 8. And then you can, let's say, want to reshape it to 4 cross 2. That's valid. But you cannot reshape it to, let's say, 4 cross 3. That will not work, because the number of elements are different. So the number of elements needs to be same. That's important. And then you can have any reshape. Any reshape will work. You can take 1D to 4D, or you can bring 4D to 1D. Both are okay. Okay. So here you can see I had a 2D array. And after reshaping, you can see that it's still 2D array. Okay, it's still 2D. But I have converted it into a different kind of 2D array. Okay. And similarly, we can cast it very similar. So what is typecasting? Jirila, I think you are chatting with someone, but you are posting it to everyone. Is that really required? Now, I could take constants, or I could take a tensor type and I could cast it. So let's say I have a floating point. Okay, guys, you can see these are floating points. Now, if I were to cast it to an integer, what would be the outcome? Yeah, data type. Yes, you are absolutely right. So this is what we are trying to do, right? We are trying to do. We are trying to convert the floating point to integers. Now, guys, how will the change look like? If I take this array and convert, right now you can see I've initialized it as float 32. But then I do tf.cast. I provide this tensor, but then I'm saying now let's cast it to integers. Now, floating point and integers are compatible with each other, so it should not be a problem. But what would be the outcome? Yeah, decimal points will be just eliminated. No rounding up, no rounding. This is fundamentally always rounding down, if I have to say it. It is fundamentally always like rounding down. There is no rounding up because the decimal is taken out. So even if you had 3.99, if you were to convert it to integer, it will become 3, it will not become 4. Okay. Yeah, it will apply that int function to all of those elements. Absolutely right. Okay. And similarly, one could do linear algebra operations like transposition. You can do matrix multiplication. Okay, so like, what is the transpose of a matrix? Let's say if I were to take a matrix, and if I were to transpose it, then what happens? Oh no, sometimes then we do not require decimal points. We want to reduce our complexity. Okay, so we could convert it to integers, although that's not prescribed. Actually, neural networks, we would not do that. Yes, but sometimes to reduce computation, some people try to do that. Okay. Okay, what is transpose, by the way? Yeah, the rows and columns are interchanged. So if I were to write as transpose, how will it look like? Right, rows becomes columns, columns become rows, something like that. Remember that. And this is what I have tried to do here. So you can write tf.transpose, you can provide a matrix, and it will just transpose that matrix. We can also do matrix multiplication, right? We can also do matrix multiplication, and we can take matrices and vectors, and using a matmul function inherently stands for matrix multiplication. One could run a matrix multiplication, although there is a constraint. Do you know what is the constraint in matrix multiplication?
Like columns of first matrix and rows of second matrix should be same.
Yes, perfectly correct. If we are dealing with m into n, m means m columns, n is number of m is number of rows, n is number of columns. Then the second one has to be like something like, let's say, n into k. So the outcome, that matrix that you are going to get, let's say you're trying to do multiplication. So the outcome matrix would be m into k. This is called conformability. The conformability factor has to be there. Otherwise, it won't work. Anyways, and you can also do element-wise multiplication. You can just simply write multiply. Here, the tensor size should be same, okay? And you can have an element-wise multiplication. Okay, and all of these operations we can do very easily, and we can get identity matrix, right? So if you write tf.I, it is pronounced I, so people write it EYE. One could easily get identity matrix where central diagonal, main diagonal is all ones, and rest of the elements needs to be 0. Okay, so basically, guys, why I'm kind of showing you all this is, and you can also get like a determinant of matrix, which is again a linear algebra operation. Why I'm showing you all this is that any kind of matrix operation that you want to do, TensorFlow already has functions for this. So you don't have to devise your own logic and write things on your own. Okay. And similarly, we can do the matrix multiplication, and there is another function called tensor dot, does the same thing as matmul. Okay, it's just a little faster. That's why I'm showing you, but otherwise it's not very different. Okay, but one of the major things that any deep learning library should support is something we like to call autograd. Or let me write it properly. It should be called automatic gradient calculation. Now, guys, why do you think this is important? Automatic gradient calculation. First of all, if just explain me what is gradient. Yeah, exactly. Remember when you were trying to, or when we try to update the theta, how do we update the theta? We take theta and we can put some alpha, which could be the learning parameter, but we usually have this thing where we take the loss, j theta is the loss, and we differentiate with respect to theta, or theta I if I had to write. Now it would be a tremendous help if this differentiation part happens automatically. Okay, fine, we can do it ourselves as well, but it would be time taking. And if I had to do it multiple levels, or if we had to do it at multiple levels, this would be a really hectic task to design these systems again and again and again. Because backpropagation happens layer after layer, and designing them by yourself is gonna be a little, not little actually. As many layers you will have, it will be far more hectic for you to come up with the whole chain rule and come up with the whole differentiation formula. It is not fun, guys. Okay, let me tell you upfront, it's not fun. So what are we supposed to do? Okay, this is why any proper deep learning module usually has something called autograd. Now let me show you how this automatic gradient is gonna work. So guys, okay, first let me ask you a question. Do you recognize this formula? This is your distance, right? If you have a right angle triangle, you can think about the Pythagorean theorem, and this is like a straight line distance. So if there are 2 points, A and B, how do you get the straight line distance between them? You can use this formula actually, okay? So this is that is what it is, okay? So guys, what I am trying to do here, let's say I take A and B randomly, okay? Okay, we take it randomly, and what we do is we run something called gradient tape. This gradient tape is going to be very useful for us. Okay, so one thing you will have to do is, if A and B are not variables, if it is variable, then this step is not required. But if they are not variables, if they are simple tensors or constants, you will have to tell what to watch. So it starts to record the history of the operations applied to A or B, whatever we have utilized. Okay. Okay. And then fundamentally, let's say this is the function, this is the operation that's applied on A and B. But because we are watching B, we can, let's say, try to do DC by dB. So guys, what is DC by dB? DC by dB is the first order differential, right guys? First order differential. And first order differentials are required in deep neural network and in a lot of optimization processes. So basically what I could do is, if I were to do tape dot gradient C comma B, it is equivalent of doing DC by dB, okay? So here you will get the gradient automatically, and you do not have to calculate or devise any kind of mathematical formula. Okay, so it is like rate of change of C given to change of B. And here you can see we have the original tensors A and B, okay? Then we have C, the calculated C, and this is the gradient. This is the DC by dB. Now, what would happen if I would try to do, if I am not watching A, but if I try to do, let's say DC to dB, let's make it DCDA, DCDA. So guys, what will happen if you're not watching it? It will not throw error. A lot of people think it will throw error. No, it will not throw error. It will simply show you there is none to be calculated. Because you're not watching it and you have not defined A as a variable. Now, again, understand, they have to be variable because you understand this, right? Whenever we do these kind of things, like I cannot do dx by d5, right? That's not going to work. We cannot change with respect to constant, because see, constant is not going to change inherently. Whenever we talk about differential, it is about measuring the rate of change of one variable with rate of other variable. This is the fundamental idea, guys. This is the most fundamental idea. And constants do not really change, right? Are they? So if you're not watching DA in this scenario, you cannot get the gradient. It is not going to throw error. It just simply says none. But if you had to do it, it's a very simple thing. I could go ahead and do this immediately. I will just need to watch A this time. And then the calculation will work. And you can see this is the calculation with respect to, okay, and we can get this calculation done immediately. And similarly, I could also show you rather than if you do not want to come into all these headaches, I understand this is totally useless, of course, just simply define them as variable, and then you do not need to watch anything. And if they are variables, all kinds of gradients can be calculated directly. This is the smallest code I could show you, tf.gradient tape as tape. Make the function or whatever your function or whatever operations you intend to do. then get the gradient of C with respect to A. This is automatic gradient calculation in TensorFlow. And you will immediately get your dC by dA. And if I were to also convert B to some kind of a variable, same thing will happen. Okay. And same thing I'm trying to show you here. That if for B, again, if I were to calculate it to a variable, I don't need to watch that. And this is what we mostly do. These things with respect or with whom we try to calculate are usually variables. Okay. Okay. And I can also take a double differential. I could also take a double differential. What is double differential? Like dx by dt is what? You might remember it as velocity, right? But if I were to differentiate x twice with dt, this whole thing and again differentiated, this whole thing again differentiated, sorry, by t, then what is it equivalent to? Acceleration. Or there's a better way of writing it. You can write it like d square x. Okay, it simply means double differential. Okay, so it is, guys, is just like a nested way of doing differentiation. So guys, could you explain me what I've tried to do here in this code block? Basically, what I'm doing is there are two tapes, outer tapes and an inner tape. Now, within the inner tape, we get the dC by dA, and with the outer tape, we again differentiate that with A, and that is equivalent to doing a double differentiation. Like if you had to calculate acceleration, this is what you would have done. And this gave you double differential. Yeah, and yes, there are different optimizations, like Newton's method is double differential. Okay, if you are using Newton's method for optimization, they don't use a single differential or first order. They use double or second order differential, and you will have to do a double differential over there. And similarly, let's say in neural networks, we use all kinds of activation functions like tanh, sigmoid, swish. Okay. These are to provide some kind of a nonlinear scenario or nonlinear activation over there to the inputs. Now see, when you will differentiate it, you will also need to know the differentiation of these things. Now maybe you know all the mathematics and maybe you can do all of this by hand, but it would be, wouldn't it be easier if the differentials are automatically calculated? And this is the good thing. If a function is end-to-end differentiable, it means it needs to be continuous end-to-end. So as you can see, this is the tanh curve and is end-to-end differentiable. Okay, at any point it will get differentiated. So what could I do is I could make up a function. Okay, I could make up a function. Let's say this returns the tanh outcome. So you provide x and it will return you the hyperbolic tanh. Tanh means hyperbolic tanh. Okay. And then I pass the data. So basically I pass the data into this activation function, getting the outcome. And with y is then differentiated with respect to x. And that gradient is returned. And then basically to run this, I can provide any value. And for that value, it will tell me the differential. So let me show you how this works. Now, guys, as you might understand, okay, guys, just look at the shape of this curve. Can you tell me where the slope is going to be highest or is going to be really a big number? Around the center, around 0, if you were to provide this value. So let's say we provide a value, very small value. Okay, so what I will do is I will provide a small value like 0.01. And you will see that your gradient value, gradient is nothing, it's just the tan theta. You see that 0.999899 is very large value. And this is as close to 1 as possible. And guys, this is the highest gradient you are going to get with tan at any point. Beyond anything, let's say if I were to go till 1.2, then what would happen? You will see that gradient will reduce. See, our gradient value is reducing. And guys, as I will go to extreme, just observe this. As I will go towards any extreme, what would happen? Let's say our value were to be 4, then what do you think will happen? It will flatten out. So if it flattens out, so your outcomes, let's say I say 4.21, it will be very close to 0 or almost 0. Yeah, you can almost call it 0 itself. You can see the gradient value is really small. Right, and similarly, I could do the same thing. Just put a negative sign here. Just put a negative sign in. And you will see similar observations from the negative side as well. It's kind of like very symmetric in that. fashion. And you see even on the negative side, it flattens out, and let's reduce this number to 1.21 and see what happens. Negative 1.2. And you see again, we get a small value because again, negative 1.21. The slope is not that sharp as it would have been close to 0. But see guys, this is a very good news for us. This is extremely good news for us because now we can do differentiations very easily. And a simple example I have tried to put it here. Now guys, if you have not done machine learning, I will not go in this example, okay? But if anyone is interested how a simple machine learning or linear regression form can be generated and how we can do all of those same tasks here, it's fairly simple and we have tried to do that here. But it's okay, we don't have to cover this. Now guys, you might be thinking, okay, fine, we define all this, but how do we create neural networks? Guys, so neural networks are fundamentally matrix operations. So you can see that for matrix operation, TensorFlow is amazing. And then we have to have these mathematical functions like tanh and everything. And you can see all of those functions are also available, right? tf.tanh is available, plus gradient is also available. Gradient is the slope value, right? Gradient is also already available to us. And that makes our life very easy. So guys, tomorrow, we are going to look into tf.keras, okay? tf.keras is like, sorry, 1 minute. tf.keras has some amazing functions specifically, and this is highly optimized to build neural networks. So tomorrow what we are going to do is, we are going to look deeply into Keras first, that how Keras works, why we prefer using Keras, and then we will show you some neural networks. Yeah, Harsha, please go ahead. Hey guys, and we have posted a lot of links for you guys in the chat. Please feel free to reach out to us and join our communities over Telegram, Facebook, Instagram, YouTube. Okay, we always post interesting content for you so that you get to learn something. Okay, so do follow us there. Harsha, did you have any question? Yeah. I saw that you raised your hand. Yeah, then so mathematically, that's the whole idea, that you want to do these operations, but sometimes some manipulations have to be done to the tensors. Mathematical manipulation that will be required by the neural network. And those mathematical manipulations, we do it again and again, layer by layer, try to correct the loss. And the hope is it gets to learn something from the data. Okay. So guys, once again, here at Learnbay, we are conducting some incredible courses around data science, full stack development, and even master's program in data science and AI. And feel free to reach out for us to for counseling purposes. Okay. And Learnbay team will be extremely happy to help you out in any problem or any issues that you have. And if you want just simple counseling, again, you don't have to register for courses. You can get simple counseling all free, completely free. And again, as you know, these webinars are also free for you, so it should not be a problem, right? So then to answer your Harsha, sorry, to answer your question, PyTorch also uses something called Tensor. Yes, almost all the deep learning libraries use Tensor type of stuff. That's easy to scale and easy to parallelize actually. Okay. All right, guys. So tomorrow we are going to continue, but tomorrow we will focus a little bit into tf.keras, one very specific library within TensorFlow, which is meant for deep learning and neural network design. And that is what we are going to look into. So again, guys, I will see you tomorrow at 9:30 a.m. to till 11:30. And tomorrow we'll try to build some small neural networks. Okay. So guys, I hope you got to learn something interesting, and you have an amazing day. Take care. And we will see you tomorrow. Okay, guys, take care. Bye-bye.